Okay, so for this one, our future value is 1,000 times 1, 2, 3, 1 plus, what goes in there? 0.09 divided by 1. Yeah, once a year. To the power of 1 times 10, otherwise known as 10, minus 1, close, divided by, open, 0.09, divided by 1, close and close. I left out the divided by 1s just to make it a little quicker. But I get 15,192.93. How many of you got that? Good deal. What's that? You didn't? Oh, yeah, you don't have to divide by 12 there because it's paid per year. Yes.
Okay, so obviously, like the next assignment is all going to be these problems, but I'm
Yep.
just, how are we going to know to use this formula or the other one to find the future value?
We're going to go over that. The biggest thing is, if you're using the other one, they're going to give you just one amount. It's going to be, if you invest this amount, what will the future value be? This is per year, per month, per quarter, per something.
Okay.
So this is, they're making multiple payments of that amount rather than just a single payment.
And you probably have a reporter, right, from when we found
Not necessarily.
that would make it easier for me to, you know.
Yeah, I know it would. But realistically in math, the biggest skill is looking at a problem, identifying what it's asking for. Doing it is actually relatively simple once you've identified it. Because in these formulas, as ugly as they are, once you know that's the formula you have to use, it isn't that tough to enter it once you've practiced it a little bit. How would we find the amount of interest? Now, I'm not talking about an effective rate. That would be way too complicated of a calculation for us to do on this one right now. But the actual amount of interest earned. To do that, it is the payment times number of payments. Gives us the actual principal. So here we had $1,000, right, times 10 years. There's a principal of $10,000. That's what he actually paid in of his own money. So the interest is that future value of $15,192.93 minus $10,000. That's an interest of $5,192.93 that was earned over that 10-year period. Now that doesn't sound like a lot of interest for 10 years, but think about it. He started out with nothing, and the balance slowly built up. So technically that balance has only been in there part of the time. It'd be very different if you put in the 10,000 right away and you only ended up at 15,000.
So the 5,000.
That's the interest earned. Yeah. In your book on page 501 to 501, 501 to 502 is a table. And I did this problem the way I did specifically so it would fit into the table. We have 9%, and since it's yearly, it is just 9%. And 10 years, so yearly would be 10 periods. So the 9% is actually on 502. We do the 9% for 10 periods, gives us 15.193. What that is saying is that takes the amount of payment times that factor, gives us our future value. So we take our $1,000 payment times that factor of 15.193, gives us a future value of $15,193. Notice once again, that is off by like 7 cents. In my math lab, most of the problems want you to use the table. If you use the formula and you're off by 10 or 15 cents, again, let me know and I will make sure I regrade that. I pretty much go through all the quizzes before I transfer them to Blackboard at this point in the course. But don't get discouraged if you're off by just a few cents if you're using the formula. As you can see, this is rounded off. It loses 2 decimal places. Our formula 2 decimal places beyond what that one did. You'll be off with the table. The formula is on. The formula is correct. But unfortunately, my math lab uses the table, so my math lab is technically rounded off.
Okay, so when you're working in this, you just,
Well,
I
they
don't
give
know,
us
it's not gonna be that way in the
They
test,
give you the table to use if you want to use the table.
but on the test, you're gonna.
On the test, I have both answers,
Oh, okay.
if it can be used in the table. A lot of times on the test, I'll give you a percent that doesn't fit the table. Well, like I said before, I think the formula is easier myself. So we're going to have you try another one. Pete invests $200 a month at 8% for 30 years. Find Pete's future value for me. Tell me what to put in. Times 3 open parentheses, yep. Point 08. By 12 because it is per month. Power of 12 times 30. Minus 1. Close parentheses, divide by. Open, 0.08. Divide by 12, close and close. $12 times 30 is just 360, so I'm just going to put that in. I'm getting $298,071.89. How many of you came up with that? $298,071.89. Yes? No? Good. Now, just to figure out the amount of interest, $200 times 360 payments, because it's 12 times 30, is only $72,000 paid in, correct? So that comes out to interest of $226,071.89. That's a pretty good return. Any questions? Yes, sir. Self-discipline. I didn't realize that that's the only answer I can give. You know, even if you did half that, $100 a month, which really isn't anything when you think about it, we probably spend that much at the gas station buying an extra soda on our way into school or work every day. Realistically, I mean, if you're spending $2 on whatever at the gas station every time you come to work, $10 a week, yeah, that's $50 a month. And that would get you a good share of the way to this. But even at $100 a month, that's $150,000 almost that you have. Yeah, it's just a matter of self-discipline.
Does the interest fluctuate on an annuity like it does on, say, a CD or market?
It all depends on how you invest it. And I'm not a professional investment planner, so I'm not going to get into a lot of detail on it. But you can put annuities into like market fund annuities, where it's like a mutual fund. So the interest does go up and down. Or you can put it into a bond annuity where it's a guaranteed interest rate. It'll be a little bit lower interest rate, but it'll be guaranteed.
Yeah.
But most annuities during the accumulation phase, you can get that variable. But most of them, when you're doing the liquidation phase, they are fixed. So that the amount stays relatively same. There are some that are not fixed, that are still variable interest rate. And what happens there is if the interest rate goes down, your monthly payment goes down.
Oh.
So you start getting less. Okay, let's take a look here. Let's say Pat invests $300 per month in an annuity due at 12% for 15 years. Find future value. So on this one, everything starts out the same. So through parentheses, 1 plus 12 is 0.12 divided by 12, because it is per month. So the power of 12 times 15 or 15 times 12, yep. Minus 1 close divided by 0.12 divided by 12, close and close. That is all the same. That's the exact same formula we just used. The difference is we'll hit equals at that point. Then we'll hit times 1 plus 0.12 divided by 12. That factor, that adjustment factor, is 1 plus the rate divided by n. So we're at 300 times 1, 2, 3. 1 plus 0.12. Let's get back there. Divided by 12, close. Power of 12 times 15 is 180. Arrow up minus 1, close. Divide by, open. 0.12 divide by 12, close and close.
For the first part of that formula, the 0.12 divided by 12, is that always going to be the same as the first? Yeah.
This and this
Yeah.
and that, yes. Yeah, those will always be the same. So 149, 874.06. Now we're not done yet. We still need to multiply by that adjustment factor here. I just wanted to write that down. So times, parentheses, 1 plus 0.12 divided by 12, close parentheses. 151, 372.80. So the difference is this was paid in per month. This formula here, the regular formula, is assuming that the payments are made at the end of each month. So the last payment is made at the very last day of the annuity. The annuity due assumes the payments are made at the beginning of each month. So that the money is sitting there for a whole extra month and drawing interest. So that's all this was, is compounding the interest for one more month. You can see there's a difference of $1,500 in 1 month's worth of interest. Move that a little bit. If I have a timeline here, and it doesn't matter how many little periods you have here, each of those little spaces represents a period. In ordinary annuity, you make payments at the end of each period. And there will be a payment at the end here. But in the ordinary annuity, there is no payment at the beginning. Payment is made at the end of that first period. And then the annuity due I get a different color than that. That ain't gonna work. Payments are made at the beginning of each period. And there is no payment made at the end. So what you can see is happening here, the difference between the ordinary annuity and the annuity due is every payment is 1 period earlier. So when you get to the end, you have one more period that's just going to sit there for an extra period and draw interest. That's what this adjustment factor is all about. Any questions? Okay, well then let's keep going. Chris invests $500 per quarter in an annuity due at 10% for 25 years. Find the future value. I'm going to give you guys a few minutes to try that one on. Let's see how you're doing. So we have 500 times, we have the 3 open parentheses, 1 plus 0.10 for 10%, divided by 4, good, it's per quarter, to the power of 4 times 25, or 100. Minus 1, close, divided by, open, 0.1, divided by 4, close and close. Now remember, I hit equals there. Then we're going to divide by 1 plus, or not divide by, sorry. Divide. We're going to multiply by 1 plus 0.10 divided by 4. So 500 times 1, 2, 3. 1 plus 0.1 divided by 4. Power of 100. Arrow out, minus 1, close. Divide by open, 0.1 divided by 4. Close and close. It equals. So that would be 216, 274, 33. So that's after, if that were a regular ordinary annuity, but since it's an annuity due, we multiply by, open parentheses, 1 plus 0.1 divided by 4, close, and equals 221, 681, 19. So another 5,400 bucks for an annuity due. What do you think? Why was that such a big difference compared to the last one? Well, because the last one was paid in monthly, it only sat there for an extra month. Since this one was paid in quarterly, it sat there for a whole extra quarter, for 3 times as long. Okay, so Pete invests $100 per month. Notice I'm only going halfway across the page right now. At 7% for 20 years. Tom invests let's see here. $6,000 at 7% for 20 years. My question is this. Who will have more? Now, you'd asked this question earlier. How do we know when to use this formula and when to use the formula from last week? This is the example. Both say, yeah, Pete invests, Tom invests. The difference is per month, and this is just $6,000, period. So this is last week. That's a future value of compound interest. This is this week. It's an annuity. So I want you guys to try each of those and find the total and see where they come out. I'll give you a few minutes. Let's take a peek here. So for the first one, get out of there. That future value is going to be the $100 times 1, 2, 3. 1 plus 0.07 divided by 12 to the power of 12 times 20 minus 1, close, divide by, open, 0.07 divided by 12, close and close. What's that come out to be? So 5209.67. Does everybody else come up with? Perfect. So let's look at Tommy over there. His future value is going to be $6,000 times 1 plus 0.07 divided by 12 to the power of 12 times 20. What's that one come out to be? What was that? 24,000? 43? Is that what everybody else got? Okay. So, even though $6,000 sounds like a lot of money to start out with right now, Pete's going to come out way better. Now, Tom's only paying in the $6,000. Pete is paying in $100 times 12 months a year times 20 months. He's actually paying in over the time a full $24,000. So here's the question. Make it equal. How much would Tom have to start with? See if you can figure that one out. This one isn't as tough as it sounds. Present value, what Tom would have to start out with, would be what Pete ends with, the $52,092.67 divided by, because we're going to a present value, we're going the opposite direction, 1 plus 0.07 divided by 12 to the power of 12 times 20, power of 240. Maybe we gotta clear that out first. Gives us 12,898.25. One of the reasons I like doing this problem is look at the comparison between this number and that number. The reason I'm pointing that out is you look at what the lump sum would have to be. It's actually about half of what the total payments would be. Think about that. Making $100 a month is the same as putting away $12,000 all at once. Okay, so that's really about it for new material. So what I want to do is give you a brief overview of next week. I know we're going to be cutting it really short tonight, and we'll probably be cutting it fairly short next week, just because with these formulas, I don't want to be giving you overload. So a brief overview for next week. We're going to be talking about liquidation phase. Like I said, in the liquidation phase, you have this lump sum, this large amount of money. And you are slowly drawing out payments. Until it gets down to zero, nothing. I realize I have this beautiful illustration, right? What's that? So it's kind of the opposite. Now, we mentioned loans. Loans are the same thing. Loans start out at a lump sum balance, and as you're paying in, actually, to get it to zero. But think of it as like you're drawing out against the balance. Your payments are drawing out against the balance that you owe. You've been given the lump sum, and you're paying them back in. Yes?
Is this where you said that we are going to divide the formula?
It's going to be actually the same formula, only we would divide. And actually, that's a good question. What if we have a certain amount of a lump sum, or we want to have a certain amount of lump sum? We want to have $200,000 in 30 years. If we can earn 8%, add 8%, how much do you have to put away per month? So this is exactly what you're...
This can be done per year.
Yeah, it can be per year, per quarter, whatever, yes. So now you're trying to find the payment amount off of the lump sum. So you have that future value, lump sum of money. So yes, you are going to divide. 1, 2, 3. 1 plus 0.08. And since it is monthly per month, let's divide by 12. Open. The power of 12 times 30 minus 1. Close. Divide by 0.08 divided by 12. Close and close. So our lump sum here is the 200,000. Divided by 1, 2, 3. 1 plus 0.08 divided by 12. Close. Power. 12 times 30 is 360. Arrow out. Minus 1. Close. Divide. Open. 0.08 divided by 12. Close and close. So $134.20 a month is what you'd have to put away to get to $200,000 in 30 years. Now, I want to do a little example here that might be more pertinent to each of you. Somebody pick, how much money do you think you would need to retire? So retire at 67 when Social Security kicks in. Depends on how you want to live. Okay. Generally, they recommend about 10 years worth of pay of your salary. So who knows what your salary is going to be? Figure you make $50,000 a year. Does that sound fair? So by the time you retire, you'll be making close to $50,000 a year. You can live off a lot less once you retire because usually you don't have a house payment and you don't have to drive to work and stuff like that. But they still recommend about 10 times your annual salary. So let's say you need to make $500,000. You need to have $500,000 sitting there. Well, anybody want to use their age? 21? 31? 21?
31?
I'm just picking on you. So 21, so that would be 46 years. What's that? It's depressing you're going to have to work for 46 years, but the outcome of this won't be so depressing. Let's say you can earn 10%. We want to know how much put away each year. So what we're going to do is at the end of each year, you're going to put into like an IRA rather than into like a TSA or whatever. So that payment amount is the 500,000 divided by 1, 2, 3, 1 plus 0.10 divided by 1, because it's each year. The power of 1 times 46 minus 1, close, divided by, open, 0.10 divided by 1, close and close. So 500,000 divided by 1, 2, 3. 1 plus 0.1 divided by 1. I'm not going to put in the divided by 1. To the power of 46. Minus 1. Close, divided by, open, 0.1 divided by 1. I guess I didn't need divided by 1 again, but I did it anyway. Gives us $631.48. Well, you think that's per year. Per year, if you divide that by 12, that's $52 a month. If you get paid every 2 weeks, that's literally $26 a paycheck. I think you could afford $25 to $30 a paycheck.
Yeah.
Now, here's the thing. Let's refigure this. Now, we just said that's $52 a year. $52.62, right? What if we actually figured this out per month? Will it come out to the same amount? So 1 plus 0.10 divided by 12. Now to the power of 12 times 46 minus 1. So let's do it. 500,000 divided by 1, 2, 3. 1 plus 0.1 divided by 12. Close to the power of. We're going to enter them in here. Minus 1. Close. Divide by open. 0.1 divided by 12. Close and close. It's actually $43.13. If you're actually doing it monthly instead of per year and dividing it by 12. The reason it's cheaper is, of course, this is compounding the interest every month instead of just compounding it every year. So it makes that big of a difference. So really, like I said, $20, $25 a month, $25 to $30 a month, you're going to have a $500,000 return. Or $25 to $30 a paycheck, I should say. Not a month. That is significant. Any questions? Okay, I'm going to let you guys out of here for the night because, like I said, that's enough to confuse you for now. So, have a good week. We will see you all next week. Don't forget that there is a new quiz. That'll be due tomorrow, Friday, at 11:59 p.m. That is on last week's material, or 2 weeks ago now, the compound interest, future value and present value. There might be a couple on there on daily compounding, so you have to use the table for that one. And then there is going to be a new homework, which is on this annuity stuff. That is for next week. Have a great week.